make this process faster. Okay. So another way you can do it, you can specify how many cores, So when the workflow is executed, the number of threads the job need considered by the Snakemake scheduler, and ensure that the sum of the threads of all jobs running at the same time does not exceed a given number of available CPU cores. So anyone who learns this type of work, you always know that you don't want to specify more threads than there are cores in your system. Otherwise, you can get inconsistent results, and that's not what you want, right? The number is given with the cos command line argument, which is mandatory for Snakemake cos that actually run the workflow. So for example, you can run Snakemake -- cos 10, and this command would assume you have a snake file installed, and if you just do that, it will execute your snake file. Okay. So there's an exercise here from this tutorial, and then it goes on to show you how to generate config files, right, which you can write in JSON or YAML config file. And an example here, you got a config file and you create a config.yaml on the top of the Snakemake directory, and the configs will be loaded. So for example, we can specify where our samples are located in the config file, right? And in this case, we say, we specify samples, the first A and B, right? And now we can remove the statement defining samples from our snake file and change our root to BCF2 score. So over here, right? You can see that here our input is coming from the config. So our sample is our config samples. Yeah. So this is like a dictionary, I think, in Python, is it? It's a key value sort of data structure, right? So the samples will be read from here, right? And you can see that samples map to A and B, and therefore by specifying this with this sort of a syntax and calling the samples, we're able to assign our samples, and the BAI index again is this file, and the samples are here. And again, we specify our output, and then we specify our shell command, where we run our BCF mpylab, and we pipe our output by calling this, and we write our output file out. Okay. You can because Snakemake really is actually Python, right? It allows you to input Python functions and directives right inside your script. Okay. So in this case here, you got a function that is written get BWO map input for SKUs wildcards. That's the argument. And what this function does is that it returns the contents of your config file. Okay. So now our script is even shorter because it will execute as part of the input. Once you get the genome, it's going to execute this script or this function. So you just replace it with this, and you get your output, and you do any of the downstream processes. So if you're quite good with Python, you can see how this works very well. And something else that you can do is that often programs take parameters, or you may want to run things and specify certain parameters. In this case here, still the map, and we are specifying our RG tag, and then we're going on to specify it on the -r and just give the params.rg. Okay. So this is all great, and for anyone else, and of course you always, you can do logs. So here now you can see that our rule has input tag, keyword, we got our output, we got our params that we've defined, and now we got our log. and the threads, and this is the script you want to execute. Yeah. So if you plan out your work this way, you know exactly what commands are being run, what parameters are being run. That is really reproducible, and if you give that, and maybe you'd have the Conda environment just in a YAML file, you can reproduce the environment within which your results were carried out. Yeah, and this is also reusable, and this is also scalable, in the sense that it doesn't matter whether I'm running this on my laptop or an HPC or any other environment that supports Snakemake and Conda. Okay. Once you do that, and you specify your directory and your files, it gets very very easy. So again, goes on to talk and define protected files. And you can see piping out to the log file there. Yeah. And really nice steps and an exercise, and then the entire thread is the entire script is plotted. That includes rule plot qualities. Getting the script. It's executing a script here. That takes in a VCF file, outputs an SVG plot, and this is the plot. So you can imagine, either you're doing R and your plots, you run your analysis, and then you can plot your results in a directory or your figures. Okay, so really nice. I did want to in real life to show you a really nice script, and partly why I thought this was really relevant. I don't know. Oh, confirm your account recovery settings. What's going on here?